Now we're going to start the 6.7 notes for today. 6.7 is about the graphs of the other four trig functions: secant, cosecant, tangent, and cotangent. We're going to start with cosecant, and I'd like you to take a minute, pause the video, and copy down what you see on the screen, and then we'll talk about it and fill in the blanks together. Cosecant is the reciprocal of which other trig function? Cosecant is the reciprocal of a sine graph. That's why you see sine all over on the rest of this page. So now let's try to answer the questions. Where the sine is 0, what would be the value of cosecant? Well, cosecant would be 1 over 0, but that's undefined. Where the sine of x equals 1. Well, cosecant's the reciprocal of that, so it's 1 over 1, or still 1. So that means all of the places where the graph of sine equals 1, the cosecant is 1 at that point also. Same thing happens at negative 1. The reciprocal of negative 1 is still negative 1. So all of the places where the sine graph was negative 1, the cosecant graph will also be negative 1. When sine of x is close to 0, cosecant is would be close to 1 over 0. So it'd be something like 1 over 0.1 or 1 over 0.01. Type those in on your calculator. What's 1 over 0.1 or 1 over 0.01 or 1 over 0.001? Those numbers are getting bigger and bigger and bigger, right? So those numbers are getting closer and closer to infinity. We have an asymptote. It's undefined exactly at that point. And when it's really close to that point, it's going up towards infinity. Where sine of x is close to 1, cosecant is also close to 1. We figured that out up at the top. Now let's use that information to sketch a graph of y equals cosecant of x. If you don't already have them, there are notes and graphs for you to use in this section. So take a minute, pass those out, and then let's make a graph of y equals the cosecant of x. To make this graph, the first thing I want to do is, since it's the reciprocal of a sine graph, let's start by making a sine graph. Sine graphs go between 1 and negative 1. And I actually want to take and make a dotted line at 1 and at negative 1. Sine graphs start at 0, they go up, now we said up above where the sine is 0, the cosecant is going to be undefined. So let's make really dark dashed lines to represent where we have asymptotes on this graph. We're going to have an asymptote everywhere the sine graph is at 0. So we'll have an asymptote at 0, at pi, 2 pi, negative pi, and negative 2 pi. Any place the sine graph is 0, the cosecant graph has an asymptote. Then we said anywhere the sine graph was 1, the cosecant graph would also be 1. Anywhere the sine graph was negative 1, the cosecant graph would also be negative 1. Now what's happening as we get really, really close to 0, like right here? The cosecant graph would be 1 over that. And we said like 1 over 0.1 or 1 over 0.01 was a number really, really big up to infinity. These values, also really close to 0, when you do the reciprocal of those values, we're going to go up to infinity. But here it was a negative value. If you do 1 over negative 0.1 or 1 over negative 0.01, you would get a really small number like negative 100 or negative 1,000 depending on what you put in. So those values are going to go down towards negative infinity. We can follow that pattern all the way across the graph. So the red lines are the lines that represent the graph of cosecant. The sine graph is just in there to help us out. We can actually go back and erase it now if we want to. And all that's left, those red U's, are a graph of cosecant. The nice thing about cosecant graphs is as far as amplitude, vertical shift, phase shift, and period, they all follow the exact same rules as a sine graph. So what we're going to do, if we ever want to graph a cosecant graph, the first thing we're going to do is graph the sine graph that would go with it. We're just going to change cosecant to sine in the equation and graph it as if it were a sine graph. Then, where the sine graph crosses the midline, we are going to draw our asymptotes. Notice I didn't say where the sine graph crosses 0, because if there's a vertical shift to this graph, the midline isn't going to be 0 anymore. It's where the sine graph crosses its middle that we want to put our asymptotes. Then, at the maximum and the minimum points, we're going to put our dots. On this graph, the maximum and the minimum points were at 1 and -1. If the graph had a different amplitude or a different vertical shift, it would be at different points. But I'm going to say put dots at the maximum and minimum points. And our last step is just to draw in the U's. So there isn't very much new about cosecant graphs. We're going to follow all of the same rules for everything that we did with the sine graph. Then all we have to do is figure out where are the asymptotes, where are those max and min points, where are the max and min points, and then draw in the U's. The same thing is going to go with secant. The only thing I'm going to change is for a secant graph, that's the reciprocal of cosine. So if you want to draw a secant graph, start by drawing the related cosine graph. And then the next 3 steps are exactly the same as they were above. Let's sketch a graph of secant in your packet. We need to start by making the cosine graph. The cosine graph is going to start at 1 and then work its way down to -1. Step 2, wherever this graph crosses its midline, we need to make asymptotes. So the asymptotes on this graph are going to happen at the odd half pies, at 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and the negatives also. Step 3, put dots at the maximum and minimum points. And then draw in the U's towards the asymptotes, going from those maximum or minimum points up towards the asymptotes and down towards the asymptotes. Those red lines are the lines that represent the secant graph. On the test, to make it very clear which ones you're talking about, you have a couple options. One option would be to make the line extra dark for the line that you mean. Your other option would be, as we're making the cosine graph to start with, make the cosine graph that you're starting with dotted from the beginning. Then it's clear that that's not the graph that you mean. That's just the graph that we're using to help you out figure out where the U's belong. We have 2 examples in our packet of cosecant and secant graphs, but in case there's not enough time, this is the homework for tonight. Some of those graphs will talk about tangent and cotangent. We're going to do tangent and cotangent tomorrow, so just do the parts of this assignment that have to do with secant and cosecant tonight. Tomorrow we're going to complete 6.7 talking about tangent and cotangent. Thursday we'll do 6.8. We'll review on Friday, and Monday is your Chapter 6 test. Take a moment to write down this assignment, and then we'll do those last 2 examples. First example, y equals 4 times the secant of x over 2 plus pi minus 6. This is a secant graph. Step 1, we're going to pretend that it's a cosine graph, and we're going to graph it as if it were a cosine graph. We'll start by figuring out the amplitude, period, vertical shift, and phase shift. Pause the video, try to find those 4 pieces of information on your own. The amplitude is the number out front, 4. Vertical shift is the number in the back, that's -6. To get the period equals 2 pi over b, so 2 pi over 1/2, or 4 pi. To get the phase shift, set the part in the parentheses equal to 0, and solve for x. The phase shift is -2 pi. So to start with, we're going to make a very light or dotted line of this cosine graph. When we make our graphs, we're going to start by marking out the midline. The midline is at -6. From there, we're going to count out the amplitude. The amplitude goes up 4 and down 4. Then we're going to mark the period and cut that into 4 parts. Then we'll use the phase shift to figure out where this graph is going to start. The phase shift is -2 pi. So I'm going to mark back to -2 pi. It's a positive cosine graph. Positive cosine graphs start at the top. So at -2 pi, it's at the top here at -2. It'll be at the midline at -pi, at the bottom at 0, midline at pi, and back to the top at 2 pi. I'm going to make this really light if I were using a pencil. Since I'm not using a pencil, I'm going to make it a dotted line. This is just to help me out. This isn't the answer. It's just a graph to help me get the answer. because my answer should be a secant graph, not a cosine graph. We need to draw in the asymptote. The asymptote is going to be where this graph crosses the midline. So we need an asymptote at negative pi and at positive pi. Then we go to the max and min points and draw our dots. And we make the u's going towards the asymptotes from those two dots. There's one complete cycle or one complete period of this secant graph. We'll do the same thing on this last example. Y equals 3 times the cosecant of x over 2 minus pi over 4 plus 2. Cosecant is the reciprocal of sine, so we're going to start by making the sine graph. Pause the video, make the sine graph on your own. This sine graph has an amplitude of 3, a vertical shift of 2, a period of 2 pi over 1/2, or 4 pi, and a phase shift of pi over 2. So to sketch this graph, we're going to start by marking out the midline, count up and down for the amplitude, mark the period, cut it in half again, and then do the phase shift. The phase shift is only 1/2 pi. That's not labeled on my graph, so I need to label it on my graph. I need to add it. There's 1/2 pi. Now since everything's going to be shifted over 1/2 pi, I actually need to add in all of the halfway marks all the way across my graph. So I need to add in 1/2, 2 halves, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6, 7 pi over 2, 8, and 9 pi over 2. Those markings that I just added, those are going to be where the important features of this graph are, because they were all shifted over pi over 2 from where they would have been originally. It's a sine graph, positive sine graphs. They start in the middle. They go up first. So here at 3 pi over 2, we're at the top, back to the middle, bottom, and middle again. Notice that I'm using the halfway marks. So nothing important is happening at pi, 2 pi, 3 pi, and 4 pi. The important parts of this graph are happening at those halves because of the phase shift. Now that black line is the sine graph. We are actually trying to draw the cosecant graph, so it would be better to make a dotted or a very light pencil line for that graph. For our graph, for the cosecant graph, we're going to go to where it crosses the midline and put asymptotes in. Then go to the max and the min points and put our dots. And fill the U in towards the asymptote. There is one complete cycle or period of this graph. We'll talk about tangent and cotangent tomorrow. For tonight, do the secant and cosecant parts of that assignment, and I'll be back in class tomorrow. Otherwise, I can see you in this room at 7 o'clock tonight if you need some extra help.